Hi, welcome back. So we continue with the transformer construction. Basically, transformer consists of up to 21 element or could be more. It's depend on the transformer manufacturing and the transformer application where we install the transformer actually. As can be seen on the figure, the yellow one is the tank enclosure, the green is the conservator tank, this one is the bushing for the high voltage and low voltage terminal connectivity, and then all the elements here you can refer detail in the slide. For detailed design of the transformer, especially for the transformer core, the core itself is not solid steel, but it consists of several quantity of laminated steel with a minimum gap to provide a continuous magnetic path in the transformer core. The advantage by using the laminated steel is we can reduce the eddy current loss in transformer. Basically, the laminated steel consists of high silicon content and it was treated by heat to reduce the hysteresis loss in the laminated steel. As can be seen on the figure, so this is the shape of a laminated steel. So it has been cut in shape of E, I, and also L. And the figure below show how the core is assembling in the transformer. In terms of transformer classification, the transformer can be classified into two types, which is a core type and also the shell type. So as can be seen on the figure, the core type, for the core type, the low voltage and high voltage winding is sharing a common core. Even though the primary and secondary winding sharing a common core, however, between the primary and secondary, it has insulated material, to separate between the primary and secondary winding. So the insulation material such as a paper, a cloth, or mica commonly has been used as a insulation to separate between primary and secondary. On the other hand, for the shell type transformer, the low voltage winding is at the top and high voltage winding is at the bottom. And also between the high voltage and low voltage winding, there are insulation to separate them. For the three-phase transformer, the three-phase transformer also can be classified into core type construction and also shell type construction. For the core type construction, as can be seen in this figure, the core is made up of three limb or leg. Three leg, 1, 2, 3, and 2 yoke. So the magnetic path will flow in this core because they are sharing a core. So if each leg will be represented by each face. For example, this leg is represented by face red. The second leg is represented by face yellow. Then the third leg is represented by face blue. So on the leg, so we have the circular winding, which is they have a primary and secondary winding in a circular because they are sharing a common core for the core type construction. the okay, for the three-phase transformer, for the shell type construction, the design is more independent because each phase has independent magnetic circuit compared with the core type transformer. So the construction is similar to the single phase shell type transformer built on the top of another. So it means that we likely have a three single phase transformer for the shell type transformer. So the benefit is this type of construction is the magnetic circuit of this type transformer is in parallel, because each phase we have, for example, phase atas kali ni, so the magnetic flux dia akan flow dalam dia punya core dia sajalah. Okay, so the advantage is the saturation effects in common magnetic paths are neglected. However, shell type construction transformer are rarely used in practice because the size of transformer is become bigger, and then the cost is very expensive because we have a three core in one transformer. Okay, for the concept and operation of the three-phase transformer, let's say we have the three-phase supply, red, yellow, and blue, and each phase will be connected to the leg of the transformer core. So when the primary is excited with the three-phase supply source, the current IR, okay, I yellow and I blue, will be start flowing through individual phase winding. So we flow to the primary winding. So when the current flow based on the Faraday law, it will produce the magnetic flux for the phase red, yellow, and also blue. So this flux will be induce the secondary electromagnetic field in respective phase, just that they maintain their phase angle between them. So when the current flow, it will produce the magnetic flux. Then the magnetic flux will flow in the core, and then it will induce the secondary voltage at the secondary winding. Okay, this electromagnetic field drive the current in the secondary and hence to the load. So depend on the type of connection used and number of turn on each phase, the voltage induced will be varied for obtaining step up or step down the voltage. So for three-phase transformer, we have a different type of connection. For example, we have a star star, star delta, delta delta, and also delta star. So the output at the secondary is depend on the connection and also number of turn. So it could be a step up or step down voltage.